Hello all, welcome to the course Electrical Measurements and Instrumentation. Um, Before that, I am Dr. M. Lakshmi Devi from the Department of Electrical and Electronics Engineering at Institute of Aeronautical Engineering. So in this course, Electrical Measurements and Instrumentation, we will discuss. So today's topic is classification of measuring instruments. So before going to the classification of measuring instruments, let us see what is first measurement, the definition of measurement. So measurement is, you can say that it is an act or result of comparison between unknown quantity and a predefined standard. So you can say that here unknown quantity is, so it is comparison between unknown quantity and predefined standard. So we can represent it in the form of a diagram as in this way. So here this is an unknown quantity. So it is called as the quantity which needs to be measured, that is called as measurand. And then so input to the process of this measurement are this is the standard or the known quantity. This is the unknown quantity and the output is the result. And here is the process of conversion. So here standard, you can say that standard is nothing but it can be an object or system that bears a that bears a defined relationship to a unit of measurement of a physical quantity. So for example, if you want to measure the weight of a body, so for that the unit of weight is kg. So we measure the unit, we measure the weight in kgs. So here, and the mass of the body which needs to be found, so that is the measurand here. So how many kgs we need to measure, so that will be the measurand. It is compared with this standard quantity, that is kg. This is the known quantity and the output will be a number. So thus measurement is nothing but quantification of the comparison. It is an act or result of comparison between the unknown quantity and a predefined standard. Next, coming to the methods of measurement, we have basically uh, two methods for measurement. First one is direct method, and second one is indirect method. So we'll see the first one, that is direct method. So direct method of measurement. So here direct method, for example, here direct method involves human interface or human involvement is there in direct method. For example, suppose we want to measure the length of a cloth. We want to measure the length of a cloth. We can directly measure it by means of a measuring tape or a ruler. You can say just uh, the length of the cloth, we get the result in the form of a numeric or a number. Then the other method is indirect method. So measurement involves indirect method is mainly used for engineering applications. Since direct method has some disadvantages because human involvement is there, so there are chances of errors. So therefore, there is another method of measurement called as indirect method. So in this indirect method of measurement, so we have a so this is a method in which transducing element transducing element converts the quantity to be measured into an analogous signal which is processed by which is processed by some intermediate means, and then supplied to the output device for display. So this is the indirect method. So it involves transducing element which converts the quantity to be measured into an analogous signal, which is processed by some intermediate means, and then it is supplied to the output device for display. So example for this is example for this is Bourdon tube. Then LVDT example. So these are some of the examples. So next is, so example for indirect measurement is speed measurement by tachometer, digital tachometer, and then we have digital weighing scale also. So these are some of the examples of indirect methods of measurement. Next, coming to the measurement system. So let us see measurement system also. So measurement system consists of the following functional elements. So these are input is given, input that is the measurand. Input is given to the primary sensing element. Next, the next functional element is variable conversion element. Next is variable process manipulation element. Then we have the data transmission. Then we have the data transmission element. And then after this we have data display or presentation. Now let us understand this. So these are the functional elements of a measurement system. So measurement system involves the quantity which is to be measured, that is the measurand, it is given to primary sensing element. So any measurement system involves these are some of the functional elements which are there in any measurement system. So some of the functional elements may or may not be present depending upon the device. So let us understand this first. So primary sensing element, it is like a primary sensor, you can say. So it is a primary sensor which actually comes into contact with the quantity which is to be measured. So it converts, so it can be a transducer. So it converts energy signal from one physical signal energy in one form to electrical energy. So it converts. So next is variable conversion element. So function of variable conversion element is, so it may or may not be there in the measurement system. So it is optional element. So example for this is suppose A to D converter. Suppose there is a digital digital input is required for the element to be processed further. So in that case, we require A to D converter. So this you can consider it as variable conversion element. So this element is required. So to provide appropriate form of the signal to the element to the next stage of this measurement system. Next is data manipulation element. So data manipulation element, so for this you can consider as electronic amplifier. So data manipulation element, what it does is it changes the amplitude of the signal. That means it magnifies it can be a magnifier. For example, electronic amplifier. So input is uh, electronic amplifier amplifies the signal level. Next is data transmission element. So suppose if any measuring system involves, so there are two elements which are physically separated from each other, then in that case, to link those two elements, we require a data transmission element. For example, spacecraft. For example, spacecraft system. So for spacecraft, the monitoring of the control station is present on the Earth, whereas the spacecraft is um, spacecraft and its monitoring system or the control units, they are physically separated. So in order to for data transmission, we require this data transmission element. Next is data presentation element. Data presentation element is the device which actually displays the output to the person for monitoring purpose or for anything. So example, um, we can consider this as a displaying device. So this is the last stage of measurement system. So with the help of data presentation element, we actually, or the person who monitors, we actually um, get the output in the form of a number. So this is about measurement system. Next, define instrumentation. So coming to the definition of instrumentation. So instrumentation is nothing but it is a combination of all the devices which are used in a measurement system. So whatever the elements we have, like primary sensors, then data manipulation elements, data transmission elements, combination of all this comes under instrumentation. Next is come the actual topic, classification of measuring instruments. So coming to the classification, instruments we can mainly classify into three types: mechanical, electrical, and electronic instruments. So we are mainly concentrating on electrical instruments. So therefore, we'll see the classification of electrical instruments. So electrical instruments are classified into two types. So first one is absolute and the second one is secondary instruments. Absolute instruments, these are also called as primary instruments. Absolute instruments, they are also called as primary instruments. And then secondary instruments we can again classify into two types, analog and digital. Now let us see in detail about each one. First one is mechanical instruments. So what are mechanical instruments? So as you know, mechanical instruments, so there is mechanical movement. It depends upon. So these instruments are reliable for static and stable conditions. So for uh, example we can take it as vernier calipers or micrometers or a measuring tape, you can say. So their mechanical movement is there. So these instruments, they have moving parts, hence they are unable to respond rapidly to measurements of dynamic and transient conditions. So these instruments are advantageous only if the quantity which is to be measured, it is static and stable. Then these instruments are noisy. So this is one of the disadvantage of noise mechanical instruments, since it involves movement. So there is noise also. Then apart from that, there is wear and tear. Then all this comes into picture for mechanical instruments. Then they are cheaper in cost and durable also. So um, so this is one of the advantage of mechanical instruments. So cost wise they are cheaper as compared to other instruments. Next is electrical instruments. So electrical instruments mainly depend upon the electrical power supply for indication purpose. So they require a source. Electrical methods of indicating the output of detectors. They are more rapid than mechanical methods. So here in electrical instruments, actually the instruments which we are going to study are electromechanical type. So here what we require is for ammeter, voltmeter, we have electromechanical type ammeter, then voltmeter, wattmeter, etc. So for this voltmeter, etc. So in order to get the output, electrical power supply is required. So the quantity which is to be measured, so that is the measuring given, and the output is in the form of a mechanical. There is a pointer on the scale, and there is mechanical movement of this pointer on the scale. So this is how the data presentation element is there in the electrical instruments. So these instruments, they depend upon mechanical meter as an indicating device. So the actual output we get, that is in the form of mechanical movement. Next is this mechanical movement has some inertia. So due to the presence of mechanical movement, so it has some inertia, due to which the frequency response of the instruments is poor. So that is one of the disadvantage of electrical instruments. Next, coming to electronic instruments. So example for this is multimeter. We have multimeter, then oscilloscope, etc. So electronic instruments, they use semiconductor devices. They are fast in response. So this is one of the advantage of electronic instruments. In electronic devices, the only movement involved is that of electrons. The response time is extremely small owing to small inertia of the electrons. So the disadvantage of mechanical instruments, they are removed here in case of they are overcome by means of electronic instruments. So with the use of electronic devices, even a weak signal can be detected by using preamplifiers and amplifiers. Next, we have seen that absolute instruments. So electrical instruments we can classify into mainly two types. So electrical instruments, they are again classified into mainly into two types: absolute and secondary. So first we'll see the absolute type of instruments. So what is absolute instrument? It is also called as primary instrument. Absolute instruments are also called as primary instruments. So these are the instruments which give the magnitude of the quantity under measurement in terms of physical constants of the instrument. So example for this is one tangent galvanometer, then Rayleigh current balance, absolute electrometer. Here is an example. You can see the picture of tangent galvanometer. This is a tangent galvanometer. You can see here there is a needle here and there is a scale marked. So this is circular. There is a circular scale and the needle will point to the scale. So these are the you can see here, these are the tappings. So by means of which current is fed to these screws, and these are connected. You can see here there is a circular coil. So there are circular coils here which is vertically mounted. So this tangent galvanometer is when it is subjected to two magnetic fields. So there are two magnetic fields. One is the Earth's magnetic field. One is the Earth magnetic field, and the other is because of the current supplied by this uh, to the circular coil, another magnetic field is established. So one is because of the current supplied to the circular coil. So there is another magnetic field established. So when there is a balance in and the needle is suspended in between the two magnetic fields, as you can see here, this is the compass. The needle is suspended in between two magnetic fields, and when there is at equilibrium position, it will become stable. So it will become stable at some position. This angle is given by theta, and this is nothing but the horizontal component of Earth's magnetic field. And this is the magnetic field which is supplied because of the current. So this current needs to be measured. So with the help of tangent galvanometer, what we measure is current. So that current is supplied to this circular coil, and this current will produce its own magnetic field that is given by V, and then Earth will have its own magnetic field that is given by VH, and under equilibrium conditions, so it will be suspended at some angle, so that angle is given by theta. So we can write the relations here. We can the current is given in terms of theta, so this is also called as tangent law. So current we can find by tangent law. I is proportional to tan theta here, where I is the current which need to be measured and tan theta is this angle. Theta is this angle. So we have a relation B is equal to BH tan theta at equilibrium. So we also have that B is equal to mu naught N into I by 2 into R. This is the magnetic field which is produced by the circular coil. So at equilibrium position, this B both are equal. So BH tan theta is equal to Ni by 2R. This is mu naught. From this we can write I in terms of, so I is equal to tan theta divided by mu naught into N. So from this we can write I is proportional to tan theta. Proportional to I is equal to K tan theta, where K is equal to this term, where K is equal to 2R Vn by mu naught into N. So this is how a tangent galvanometer works. So these are absolute instruments are advantageous in the sense that they do not require any calibration. So these are primary instruments which are mostly used in standard laboratories. So they do not require any calibration, and these are used as standard instruments in various institutions and research organizations. Where accuracy is preferred, so there we use absolute instruments. Next is secondary instrument. Secondary instruments are constructed such that the quantity being measured can only be measured by observing the output indicated by the instrument. That means the quantity which is to be measured, suppose we need to measure current. So we have ammeters. We have an instrument called as ammeter to measure the current. So there is a pointer and scale is there. There is a scale here. This is a pointer. So on this there are marked from 0 to, so this maximum value indicates the range of the instrument. Suppose this is 5 amperes. So output we get in the form of, so output is indicated on the scale. So these type of instruments, they are called as secondary instruments. So directly the quantity which need to be measured, that is observed. So that type of instrument is called as secondary instrument. So these are calibrated by comparison with an absolute instrument or another secondary instrument which has already been calibrated against an absolute instrument. So main disadvantage with this is they have to be calibrated from time to time to avoid errors. So what is calibration is to compare. Calibration is done at regular intervals of time to compare. It is just a comparison between the unknown quantity with a standard or a known quantity. So calibration involves comparison of standard or unknown, in the sense the device which is to be tested. The device to be tested with the standard. It is comparison of device which is to be tested with a standard device. So calibration is done at regular intervals of time to avoid errors, and also to make any slight adjustments so that the instrument is working. This is done to check whether the instrument is working, is giving accurate readings or not at regular intervals of time. Next is analog instrument. So secondary instruments, depending upon the type of display, we can classify them into two types: analog and digital instruments. So analog instruments, they are defined as the instrument whose output is, so here the output, its output is a continuous function of time, and they have a constant relation to the input. So physical quantity, example for analog instruments we have are ammeters, voltmeters, so that we'll see in the next classes. Physical quantity like voltage, current, power and energy are measured through analog instruments. Most of the analog instruments, they use pointer or dial for indicating the magnitude of the measured quantity. So that is what we have discussed just now. So they use a pointer or a dial for indicating the magnitude of measured quantity. Next is digital instruments. So these instruments, they represent the measure and value in the form of digital number. So nowadays, we have digital thermometer where we get the temperature in terms of, example for this is digital thermometer. So we actually get the temperature in the form of numbers. And next we have digital oscilloscope also. Etc. These are some of the examples. It works on the principle of quantization. Quantization is nothing but it is a process of converting the continuous input signal into a countable output signal. So coming to the advantages, so the construction of this is complex, but the cost is very high. These are some of the disadvantages of digital instruments. Construction of the is very complex, but their cost is very high. They consume very less power. So this is one of the advantage you can say as compared to analog instruments. So example for this are digital multimeter, digital voltmeter, digital frequency meter. So all these are some of the examples of digital instruments. Next, we can classify analog instruments. So, based on these criteria, first is the based on the principle of operation. Next is based on the method of representation. Based on the measured quantity, based on the current which is to be measured. So, we'll see one by one. First one, based on the principle of operation. So, here we can classify the instruments into 5 types. First one is based on magnetic effect. Next one is thermal effect, electrostatic effect, then Hall effect and induction effect. So we'll see one by one. Magnetic effect, first one. So magnetic effect is nothing but, so whenever there is a conductor, whenever current is flowing in the conductor, induces magnetic field around it. So if you have a conductor which is carrying current, so there will be magnetic field associated with the conductor. So here the conductor is converted to, consider the conductor is converted into the coil. The summation of magnetic field of the coil will behave as an imaginary magnet. So what is magnetic field is, you can see here. So this is a conductor. So when current is passing through this, so and when it is placed under the influence of another magnetic field produced by some electromagnet, so the magnetic field is distorted. So field is distorted. This is based on the working principle that when a current carrying conductor is placed in a magnetic field, so conductor will experience a force. So there will be, the conductor will try to move. Next is induction effect. So induction effect, this effect is Example for this magnetic effect are ammeters. We have a meter of the type PMMC meters and MI instruments. So based on magnetic effect, we have two types of instruments, PMMC instruments and MI instruments. Next is induction effect. So example for this is energy meter. Energy meter. So energy meter works on the principle of induction effect. So what is induction effect is, here a non-magnetic conducting disc, it is placed in a magnetic field. When it is placed in a magnetic field produced by an electromagnet, so when a non-magnetic conducting disc is placed in a magnetic field, so induces an electromotive force. So this magnetic field which is produced, that has been induced by electromagnet, which is excited by the alternating current. So the electromotive force, it will induce current inside the disc. So if it will induce current inside the disc. So interaction produced by the induced current and EMF moves the disc. So this effect is mostly used in induction type instruments or induction effects, where you can see, so induction effect is used in energy meters. Electrostatic effect. So electrostatic effect is the force. So there will be electrostatic force will be exerted between two conductors or two plates. If these two plates are charged, if there are two charged plates kept very near to each other, if one of them is fixed and the other one is movable, the other one is free to move, then due to this electrostatic force exerted between the two charged plates, so there will be uh, movement of this the other plate. So this force is used for the electrostatic force exerted between two charged plates. This force is used for displacing one of the plate. So there will be relative motion of this plate with respect to the fixed plate. The instruments which work on this principle, they are called as electrostatic devices. So we have example for this is electrostatic voltmeter. Example for this is electrostatic voltmeter. Next is thermal effect. In thermal effect, we make use of thermal effect to measure current. So the current which is to be measured is passed through a small element which heats it. So the temperature rise. So when the current is passed through the element, so there will be temperature rise. This temperature rise is converted into an EMF by a thermocouple attached to the element. So conversion of the current into EMF with the help of temperature is called as thermal effect. So this current which is supplied to the element, so that is converted into an EMF. So that is called as thermal effect. So this effect is used in thermocouples to measure the unknown EMF. Next is Hall effect. Hall effect elements, these are used in magnetic measurements. So they are used for sensing of current. So example for this is Poynting vector wattmeter. So that is based on Hall effect. So Hall effect is, if a bar of semiconducting material, you can see here, if it is placed in uniform magnetic field. So in uniform magnetic field, and if the bar is carrying current, then an EMF is produced between the two edges of the conductor. Next is based on the method of representation. Again, we have two types, deflecting type and null type. And deflecting type, again we have three types, indicating, recording and integrating instruments. So let us see one by one. First one, indicating instruments. So here indicating instruments, they make use of dial and pointer for indicating or displaying purpose. So they indicate the magnitude of the quantity which is to be measured. So they generally make use of a dial and pointer for this purpose. So voltmeters, ammeters and wattmeters belong to this category. So whatever the meters which we are using in laboratories, so they are of indicating type. Next is recording instruments. Recording instruments, they give a continuous record of the quantity being measured over a specified period. So here recording instruments, example for this is ECG. Another example is oscilloscope. Oscilloscope. So oscilloscope, then CRO, that is cathode ray oscilloscope. So here we get a continuous waveform. We get a continuous display of the values which are to be measured. So here recording, it gives a continuous record of the quantity being measured over a specified period of time. The variations of the quantity being measured are recorded by a pen and a sheet of paper carried by a rotating drum. So, for example, is recording voltmeter. Another example is recording voltmeter also, which is used in a substation. It keeps up the record of variations of supply voltage during the day. So, not only at that particular instant of time, but it keeps record of variations in the supply voltage during the whole day. So that is recording type instrument. Next is integrating instrument. So example for this is energy meter, you can say energy meter. So an integrating instrument totalize the events over a specified period of time. If you take the summation of an electrical quantity, so that will denote an integrating instrument. So this is nothing but energy meter. Summation which gives is the product of time and an electrical quantity. Energy meters are example of this category of instruments, or another secondary instrument which has already been calibrated against an absolute instrument. So example for this is energy meter. Next, coming to null type instruments. Null type leads to determination of magnitude of the measured quantity. So null indication depends upon some other known conditions. These are more accurate and highly sensitive as compared to deflection type instruments. A DC potentiometer is an example of a null type instrument. So here DC potentiometer, then even in Wheatstone bridge, even in bridges, almost all the bridges, they work on the principle of this. So there is a galvanometer here. There are resistors placed. So this is 1, 2, 3, 4. If one of the in this 3 resistance values are known, one of the resistance value need to be found out. So that can be found out by using the relation R1 R4 is equal to R2 into R3. So from this you can find out R1 is equal to R2 into R3 by R4. So one of the resistance in one of the arm of the bridge is unknown and remaining all the 3 are known. So this Wheatstone bridge also works on the principle of also is a type of null type instrument. Next is based on the measured quantity. So what quantity needs to be measured, what electrical quantity need to be measured. So according to that we have classification. So first one is ammeter, next one is voltmeter, next is wattmeter, and the last one is energy meter. So ammeter is the instrument used for measuring current. With the help of voltmeter we measure voltage, then with the help of wattmeter we measure power. So with the help of wattmeter, power, voltage, current, energy meter, we measure energy. So this is one of the classification. Another classification is based on the current to be measured. So we have, according to this, we have 3 types: DC, AC, and combination of both DC and AC. So the instruments which work on DC, they are called as DC instruments, and the instruments which work on AC, they are called as AC type, and the instruments which work on both AC, there are instruments which work both on AC and DC also. So example for this is PMMC instrument. Example for this is induction type or energy meter. Induction type energy meter. Example for this is dynamometer type instruments. So thank you all. So with this, I would like to end.
Like, share and subscribe. Hit the bell icon for more updates.